Welcome to the Kentucky Watershed Academy. This presentation is part of Module 1 of this Academy, which focuses on the Clean Water Act and other environmental laws. This presentation is the fourth in the series that focuses on specific permit types and much more so on other environmental laws portion. We want to begin this presentation by focusing on sources of human waste entering into streams, since bacteria is a frequent issue that needs to be addressed in watershed plans. Oftentimes, the public thinks all sewer systems are the same and all water gets treated. But there are two types of systems, a combined sanitary sewer system and a separate storm sewer system. The combined system allows sanitary and stormwater flows to mix, and the combined flow goes to the wastewater treatment plant. This potentially creates large, unmanageable volumes of water for the plant, so sometimes waste is inadequately treated, or sometimes excess flows bypass treatment and go untreated to the nearby waterway. The separate system enables stormwater and sanitary discharges to go into two different systems of pipes. This reduces the treatment plant overloads, but it means that the stormwater enters water bodies untreated. The graphics indicate where these different types of overflows occur with the United States. Combined sewer overflows, or CSOs, are designed so that stormwater flows into the same set of pipes as sanitary discharges. During heavy rains, excess flows go into streams at designated locations. In separate systems, the rainwater is supposed to flow into storm pipes that are separate from the sewage. Unfortunately, water infiltration into leaky or cracked sanitary sewer pipes can cause sewage overflows as well as blockages. The maps show where these overflows occur. SSOs are much more numerous than CSOs. However, CSOs contribute much larger volumes of flow and associated pollutants. The maps and statistics on this slide and the previous slide are from the 2004 NPDES CSO report to Congress. A number of these CSOs have been corrected since that time, but this provides a state-level comparison between CSO and SSO volumes. As you can see, the combined sewer overflows had around over 9,000 CSOs per year, discharging 850 billion gallons per year from 17 different communities and 288 outfalls. For sanitary sewer overflows, the number is much higher at 23,000 to 75,000 SSOs overflows per year, discharging 3 to 10 billion gallons per year. So many more overflows, but much lesser volume for the SSOs. So again, while SSOs are more common throughout the state, CSOs contribute much greater volumes of discharge. It's important to understand the type of sanitary system that is located in the watershed area in which you are working. This information will be helpful with developing appropriate management recommendations for water quality improvements. Here you can see some of the challenges in CSOs communities. This one is in the Metropolitan Sewer District of Cincinnati, one of the top 5 CSO dischargers in the United States. 41 inches of rainfall produce 180 billion gallons of runoff. Of this, 155 gallons, or 86% flows into the streams and the rivers, but 25 billion gallons enter the combined system. This accounts for 25% of the total volume that these sewers can carry. 14 billion gallons of this sewage or stormwater mixture overflow into streams, while 86 billion gallons are treated at the wastewater treatment plant. The challenge is how to reduce the volume of stormwater entering the treatment process. The use of green infrastructure is one approach to reducing the amount of stormwater entering the system in these combined sewer system areas. Measures such as grass swales or channels, rain gardens, and vegetated parking lot islands help excess water to slow down and sink into the ground. It is also helpful to begin to separate the sanitary and the storm systems where possible. The Clean Water Act requires that each state estimate the capital cost required to meet the Clean Water Act goals for wastewater planning. The 2016 survey was not available at the time in which this presentation was developed, but the cost was $6.2 billion in 2012, with the most expenses needed to address the wastewater system repair, new systems, and the correction of the combined sewer overflows. When working with wastewater utilities in the area, it is important to know what projects are currently proposed in your area and their ranking for potential funding. The Wastewater Municipal Planning section at the Kentucky Division of Water reviews these plans with a 20-year projection in order to inform the Clean Watershed Needs Survey. If you would like to review this information, you can access it through the Kentucky Infrastructure Authority website. Under the WRIS tab, click the Management Plans option on the drop-down list and look for the Kentucky Wastewater Management Plan section. You can also review a lot of information about the municipalities and the state of the systems from the WRIS portal. In the Wastewater Management Plan, you will find the percentage of homes that are serviceable for public wastewater systems. This will give you an idea of the number of septic systems or straight pipes that you might find in your area. Here is another county-level analysis within the Bluegrass Area Development District from that same Wastewater Management Plan document. Particularly interesting is the percentage of serviceable households, meaning that these households could connect to municipal sanitary sewer lines. This will begin to help you to understand at a county level what the prevalence of sanitary sewer connections might be in the county as opposed to other connections. This plan also lists the proposed wastewater projects throughout the state. To stop violations of the Clean Water Act, the EPA has negotiated a number of consent decrees for municipalities in Kentucky. These actions include large fines, required actions for the municipality, and even outline projects that must be completed. As an example, Louisville, Kentucky had a consent decree in 2006 in which there was a $500 million fine and it addressed CSOs and SSOs. In 2008, Lexington was fined $300 million and it addresses SSOs as well as stormwater system. Moving on from the sanitary sewage system, let's look more at the stormwater permits. We talked about separated systems, and the MS4 is the name of the system that collects the stormwater separate from the sanitary sewer. It gets its names from M for municipal and 4 S's, separate storm sewer systems. So this is owned by a state, a city, or town that discharges into the waters of the U.S. It's collecting the stormwater and delivering it, but it's not combined and it doesn't go through a treatment plant. So in this graphic, we see a separated system in which the black lines represent the sanitary sewer system, which goes to the publicly owned treatment works or the wastewater treatment plant. And the orange lines show the storm sewer system, or the MS4, in which the water is delivered untreated directly into the streams or other water bodies. The history of stormwater permit is relatively short. The Clean Water Act was amended in 1987 to require the development of a stormwater permitting program. Phase 1 permits for communities with populations greater than 100,000 were required as of 1990. Smaller Phase 2 communities were required to have permits as of 1999. This map shows the location of Kentucky's Phase 1, that's Lexington and Louisville, and Phase 2 stormwater communities. Phase 1 and Phase 2 permits are similar in that they both have 6 minimum control measures to be addressed. The Phase 1 permits are more specific and also require monitoring of outfalls and inspection of industrial facilities. These are individual permits. If you have an MS4 in your watershed, they can also serve as a great partner, particularly if you can align some of your activities with requirements of their permit. All MS4s have public education and public involvement requirements. Therefore, they can be excellent partners when it comes to educating and engaging the public with regard to pollution problems in the watershed. MS4s also have post-construction control requirements for stormwater retention and detention that are specific for each area. It is important to be familiar with these requirements. The pollution prevention measure refers to specific controls for the municipal operation and facility, which will also be helpful to understand. If a TMDL has been established in your watershed, there may be opportunities to collaborate with the MS4 regarding its implementation. We will discuss some of these elements of the MS4 permit in more detail in subsequent slides. MS4s are required to have a program to identify and eliminate illicit discharges. Illicit discharges are generally anything other than stormwater that is entering the stormwater collection system. Municipalities are required to map their outfalls so that they know how to trace illicit discharges through the system. They must have a plan to detect them, make them illegal through ordinances, and have practices to address them. So MS4s can be partners in trying to track down some of these sources of pollution if it occurs within their jurisdiction. MS4s must also inspect construction sites with more than 1 acre of land disturbance. This includes having a program to review site plans, inspect facilities, and ensure compliance. If you are working in an MS4 area and notice construction erosion problems, you may be able to work with the MS4 to resolve these issues. Each construction site is required to have a stormwater pollution prevention plan to address stormwater pollution. So, if you notice sedimentation around a construction site, you should be able to work with the MS4 to ensure that the site comes into compliance. Phase 1 permits also require the inspection of industrial facilities to determine if they are contributing to water quality problems. This slide lists some of the different types of facilities that might be inspected under this program. Again, this is for Phase 1 permits and not for the smaller Phase 2 communities. If you're working in an area that has an MS4 permit, there may be some additional opportunities for working with the municipality. Many have a water quality management fee or a stormwater fee. This is usually based on the amount of impervious surface on an owner's property. This fee creates a fund that assists with the costs of implementing stormwater program and the installation of stormwater management practices. These fees may also be available for citizen-led BMP implementation projects or other uses depending on the community. Check to see what the policy is in your area. Riparian buffers can also be an opportunity to collaborate. Communities may have ordinances or zoning requirements that protect riparian buffers by establishing a construction setback zone. Ordinances may range in what is allowable in these buffer areas. For example, some require the protection of a 25-foot setback from the stream bank. Greenways may also be an opportunity for collaboration. Greenways are corridors of open or natural spaces along stream that may be managed for conservation, recreation, or wildlife protection. Management can vary from community to community. These greenway programs can have opportunities for water improvement in conjunction with recreational opportunities. We've talked about stormwater and we've talked about sanitary sewers. But in many areas of the state, sanitary sewer systems have not been constructed. Therefore, on-site wastewater treatment systems, primarily traditional septic systems, as well as some straight pipes, will be utilized to handle household sewage. Septic systems work by allowing solid materials to settle out in the tank and effluent water to flow into the drain field, where it is then absorbed by the soil and treated through microbial interactions. However, if a septic system is not pumped out regularly, the drain fields can become clogged with sludge and cause backups. These failing systems can contribute to in-stream bacteria concentrations, particularly if these systems are in close proximity to the stream. Soils throughout Kentucky are generally poor or inadequate for septic tank installation and sewage treatment. Karst features also enable sewage to flow more freely into groundwater without adequate treatment. The Kentucky Division of Water does not regulate septic systems. These are managed by the county health departments. However, when wastewater is at the surface and running into a water body, it is a violation of 401 KER 1031. Watershed coordinators should know that there is not a statewide database for septic tank owners, nor is there even a county-specific one. Records vary from county to county, so you'll need to work with the local health departments to understand where problem areas might be. Failing septic systems and even straight pipes are a huge problem in certain areas of the state where wastewater infrastructure has not been constructed. A 2001 study by Eastern Kentucky Pride and KWRI estimated that 17,000 failing septic system and 16,000 straight pipes were located in the area. Although these figures have likely decreased, this is still a huge issue for this area of the state. Not all animal feeding operations, or AFOs, are permitted, but operations with confined animals, or confined animal feeding operations, CAFOs, are permitted. AFOs that are permitted have two things. They are confined, that is, that animals are stabled or confined or fed 45 days or more in any 12-month period. They also have bare ground, that is, that crops or vegetation are not sustained in a normal growing season. If it discharges manure or wastewater into a stream, then the facility automatically qualifies as a CAFO, no matter how big or how small. There are regulations defining CAFOs and AFOs in 40 CFR 122.23. Large animal feeding operations means that the AFO stables or confines as many or more of set numbers of animals. For instance, 40 dairy cows or 1,000 other cattle, 2,500 swine, 500 horses. You can see the other descriptions that are in the law. A medium facility has 200 to 700 mature dairy cows, 300 to 999 heifers, and you can go down the list. So based on different amounts of size, they may be categorized at these different large, medium, or small levels. But the point is they have confined animals and bare ground and any discharges of manure of waste into the streams. The Kentucky Agricultural Water Quality Act is not a permitted system, but it requires all landowners with more than 10 acres of agriculture or forest land to develop a water quality plan. The water quality plan specifies best management practices related to forestry, pesticides and fertilizers, farmsteads, crops, livestock, and protection of streams and other waters. It is a way to help farmers ensure that they are protecting waterways as they conduct their farming operations. Farmers must provide their plan in order to qualify for cost-sharing assistance through federal farm programs. The Surface Mining Control and Reclamation Act, also known as SMCRA, in 1977, created two programs. One regulated current mines, performing a permitted process, and the second cleaned up abandoned mines. The Division of Abandoned Mine Lands, or AML, works throughout Kentucky's coalfields to protect the public from health and safety problems caused by mining that occurred prior to 1982. AML administers a water supply replacement program through which they extend water lines into areas where drinking water has been contaminated by past mining activity. The Division of Mine Permits ensures that permitted activity meets the human health and environmental standards of SMCRA. The Division of Mine Reclamation and Enforcement is responsible for inspecting all surface and underground coal mining permits in the state to assure compliance with SMCRA. Also responsible for regulating and enforcing laws for non-coal mining sites including extraction of limestone, sand, gravel, shale, and river sand and gravel. Sections 401 and 404 of the Clean Water Act regulate projects that involve the discharge of dredged or fill material into waters of the United States. This applies to any type of dredge or fill material, but mining activities creates dredge and fill materials, and therefore it is covered by the 404 permitting and 401 certification requirement. This certification includes management requirements for handling vegetative debris, sediment, and acid mine drainage created through the mining process. The next slide will provide additional information on 401 and 404 requirements. A biological intensive survey is also needed for coal mining permitting. The Kentucky Division of Water has specific guidelines for sampling and site of identification that are published on its website in order to guide what mining operations are required to sample. The guidelines require chemical samples as well as different types of biological samples depending on the size of the waterways. For construction permits that will potentially impact a water of the United States, two different permits are needed. The Army Corps of Engineers administers the 404 permit process, as we previously discussed. The applicant must perform a jurisdictional determination of all water resources in the construction area. This means determining whether there are any streams or wetlands in the area, and if so, determining their size or length and how much would be impacted. They are then required to assess whether these water resources are a water of the United States in conjunction with the permitting agency. The Kentucky Division of Water's 401 certification validates the U.S. Corps of Engineers 404 permit. This dual agency approach ensures that the federal and state regulatory agencies approve of the projects and have outlined their expectation for measures that will protect water quality. 404 permits, or construction permits, are issued generally in two different types: nationwide permits and individual permits. Nationwide permits are general permits for common activities with minimal impact, that is, less than 300 feet of stream are impacted or less than a tenth of an acre of a wetland. Some common nationwide permits include number 3, maintenance activities; 12, utility lane crossings of streams; 13, which is bank stabilization; 14, road crossing of streams; 21, surface mining activities; 27, stream and wetland restoration; and 39, development. Individual permits are larger impacts with a public comment period. Both permits may involve mitigation to compensate for impacts to streams or wetlands that result as part of the construction process. When significant impacts occur, the permittee can mitigate them by restoring a stream or wetland in another area, or they can pay a fee in lieu of conducting the restoration themselves. These fees are then used to professionally restore a stream segment or wetland area within the same river basin as the construction project. This fee in lieu of program, or FILO, is managed by multiple agencies but is directly overseen by the Kentucky Department of Fish and Wildlife Resources. The FILO program is provided for in KRS 150-255. Permits are also required from the Division of Water for stream construction, and that includes stream restoration work, as well as construction activity within the 100-year floodplain. The 100-year floodplain is the land that is predicted to flood during a 100-year storm. It has a 1% chance of flooding during any given year. Title VI of the Clean Water Act provides for state revolving loan funds. Through this program, the EPA provides annual capitalization grants to state requiring 20% match by the states. These low, sometimes no interest rate loans have a 20-year payback period and can be allocated towards drinking water infrastructure or wastewater infrastructure. They're mostly to construct or repair wastewater facilities, but they can go to non-point sources as well, and this includes septic repair, easement purchases, wetland purchase and restoration, brownfield conversion, and the minimization of runoff from farmlands. This diagram shows how funds flow in the State Revolving Fund, or SRF, program. Federal monies from the EPA flows to the state, and the states provide their 20% match. Bondholders, such as banks, provide additional funding, and the SRF recipients receive and pay back low-interest loans on the amounts to complete their projects. These pie charts summarize how SRF funds were used nationally in the year 2014. By far, the majority of funding was used for wastewater treatment plants and related infrastructures, though non-point sources and estuaries were funded at 4% of the total infrastructure. You can see a lot of the money goes towards secondary treatment as well as advanced treatment, 16% towards new sewers, another 14% towards sanitary sewer overflows, and 10% towards combined sewer overflow corrections. Often when the public thinks about water quality protection, they immediately think not of streams, but of drinking water. It is important to know that the Safe Drinking Water Act, or SDWA, and the Groundwater Rule, or GWR, are legislative mandates that protect drinking water supplies and source waters. These laws help ensure that the public understands the quality of their drinking water and any contamination concerns. A water body could be failing standards required for recreational use, but still provide quality drinking water after treatment and disinfection. The SDWA requires consumer confidence reports that you receive in the mail, and they have rules about disinfection byproducts, potential contamination threats to the water supply, and operator certification that are reported in these reports. The groundwater rule includes additional requirements for the protection of drinking water systems that use groundwater sources. It also requires surveys for potential contamination sources and calls for corrective action if viruses or bacteria are present. The Endangered Species Act requires that federal agencies ensure that their activities are not likely to jeopardize the existence of threatened or endangered species. If these species are present in your watershed, they may restrict some of your planned projects, but they may also provide opportunities to create protected habitat for the species. There are 49 federally threatened or endangered species in Kentucky, and 37 of these species, that is 75%, are aquatic species, including 9 fish, 2 crustaceans, and 26 mussels. If you want to have more information about what is located in your area, please see the link that's located in the slide. The last of the other environmental laws that we want to look at today is the National Environmental Policy Act, or NEPA. NEPA was passed in 1970 and requires federally funded projects to consider environmental effects and multiple alternatives through one of 3 progressive levels of analysis. A categorical exclusion is for projects that don't individually or cumulatively have a significant environmental effect. Environmental assessments, or EAs, assess whether or not the project has potential to cause a significant environmental impacts. It addresses the need, the alternative, the impacts, and consultation. An environmental impact statement, an EIS, or a finding of no significant impact, a FONSI, require more rigorous and detailed documentation with public comment explaining different decisions that were made along the way. The more rigorous the document, the more detail that may be available. As a watershed coordinator, these documents may have done a lot of the work for you. They typically consider the following impacts and provide related discussion. That is, affected environment, threatened and endangered species, air quality, water impacts, historic and cultural preservation, socioeconomic impacts, soils and geology, noise and aesthetics, energy, hazardous waste, direct, indirect, and cumulative impacts, and cost analysis. So if there's a federally funded project in the watershed area, such as a road, these documents can be very valuable references for watershed coordinators. We hope this has been a helpful presentation for you, covering some aspects of permitting in the Clean Water Act and some other aspects of other environmental laws that you may address. Thank you for attending the Kentucky Watershed Academy and Module 1 for the Clean Water Act and related environmental laws.